Hi friends, after a long time making this video for you entitled as significant figures due to some work we were unable to make new videos for you for a long time, but now we are done with our work and we can do some make videos for you. So without wasting our time we should start now. Okay, so today's topic is significant figures. So what are significant figures? The understanding of significant figures may be different for different standards students. For 10th class students or below that, it may be a new topic. For 11th and 12th class students, it may be a new topic, it may be a concept clearance, and it may be a quick and short revision. About 12th, it may only maybe a quick and short revision, and for others, it may be interesting or sometimes it may be boring. But actually, it is a very important topic for a chemistry or physics student. So, what are significant figures? The term significant figures refers to the number of important single digits, that is 0 to 9 inclusive, in the coefficient of expression in scientific notation. The number of significant figures in the expression indicates the confidence or precision with which an engineer or scientist indicates a quantity. So if I would like to explain you in a brief, suppose we measure anything, we calculate anything, we may be uncertain about something. Suppose we are given 4 upon 3, we will write it simply 1.33. But is it the real value? No. The real value is 1.333. It is still a large number. It's a still large number. You can't tell that how many trees are. Infinite trees. So you are uncertain with that. For short, you write only 1.33. Suppose we are given 1 upon 6. Yeah, how much it may be? If we calculate, then 6 upon 10, here 6 and then 404, like this. So we will get 1.666, then infinite 6 we will get. Will either simply write it as 1.66 or we will simply write it as 1.67. Yeah, means we are uncertain with this. So this uncertainty is a part of significant figure. It is a component of significant figures. Suppose we have a number 1.345. The last digit is called as uncertain digit because we don't know that we are exactly correct about the last digit. It may be a plus or minus 1. It may be either a less 1 or it may be a plus 1 or it may be the real value. We are not sure about that, but we are sure about the 1.34. We know that these are the real values. We are confident about that this is the real value, but we are not confident about the 5. Means here this confidence values plus the uncertain values combines together to form the concept of significant figures. For example, in this number, there are 4 significant figures. Here are 4 significant figures. Here are 3 are confident one and 1 is uncertain. So there are total 4 significant figures. Let me move on some more examples here. Here we have an example. Suppose we would like to calculate the number of significant figures in these questions. How can we do so? Let me see. In the first one, there are 5 significant figures. In the second one, there are 8 significant figures. In the next one, there are 5 significant figures. In 500 decimal, there are 3 decimal numbers, 3 significant figures. In the next one, there are again 8 significant figures. In the next one, we have about I can say 8 again. And in the last one, we have 6 significant figures. You can check. Am I right? No, it's not that I have made it this slide and I must know that what are the answers of my questions. This slide is made by another person and the person by which you are teaching now is another. I don't know the answers. I have calculated it now only. I don't know the answer before this. So how I have calculated the significant figures? So we will study in this video how to calculate the number of significant figures. So I think we should start now. Before starting, I have an important announcement to you that new sessions will be coming soon. So what will be there in new sessions? There will be videos related to biological and scientific concept. For example, today is also a video related to biological and scientific concept, that is of significant figures. Like this we have scientific notation, we have atomic mass number. Like this we have many biological and scientific concepts. In biology also we have gram positive, gram negative. Like this we have many scientific concepts, biological concepts. And also in the upcoming sessions we will provide you some scientific activities for home, which you can perform for home, like the production of hydrogen with the help of home available things. I will also make videos for you of daily life phenomena explanation, for example total internal reflection. After this I will also provide you contents by scientists. So what do you mean by contents by scientists? Contents by scientists means I will provide you some of the books written by scientists. For example, I can provide you the book The Origin of Species. The Origin of Species. It is a book made on the topic of evolution by Charles Darwin. Okay, like this I will provide you some contents. So for this session, new sessions, you must subscribe our channel. Okay, and also like this all the videos. Okay, so now we can move on. So type of number for significant figures. We have two type of numbers for calculating significant figures. The first one is decimal number and the second one is non-decimal number. So first of all, we talk about non-decimal numbers. For non-decimal numbers, we have a simple rule that all the numbers between the first and last non-zero number, including these non-zero numbers, are counted as significant figures. For example, we have this one. So the first non-zero number is 1 and the last non-zero number is 2. So here all the numbers between 1 and 2, including 1 and 2, are counted as significant figures. So in this number we have total 8 significant figures. If we talk about elaborated rules, there are elaborated rules. If you want to write them, you can write, but they are of no significance if we have studied the simple rule, and you don't need to study the elaborated rules. Okay, so I have provided some exercise for you. You can solve them. I will provide you 20 seconds for them. Okay, so your time starts now. Okay, so the time is over and I'm going to show you the answers of the questions. So these are the answer. I will explain you each and every answer one by one. The 5 is the first and last non-zero number. Okay. So here only there are only one significant figures in this. The first one is 6 and the last one is 5. So there are three significant figures. Similarly, there are in the third one there are six significant figures. For the fourth one, I will talk it later. Let us mark a star. For the fifth one, we have three significant figures. For the next one, we have six, and for the last one, we have four significant figures. That is from 5 to the 4. Okay. So now let us talk about 6. You may say that if we have done here in this 500, we have two zeros and only 5 is available if we have written 1. But in this there is 6, then why we didn't have written 1? Let me explain the answer. Here the 5 is the first and last non-zero number. You can say it as the first and last zero number as it contains 0 also. As it contains 0 also. Zeros are here. The 5 is the uncertain one also, and it is the confident also. Okay, so but in this sixth one, in the first one there is 5. We are confident with 5. We are unconfident with this 0. With this 0 we are unconfident, but we will not count it as it is against the rules of the calculation of the counting of significant figures for the non-decimal numbers. It is against the rules, thus we will not count it as 0. Here 5 is the confident value. We are precise with the 5, but here we are not precise with the 6. The 6 here is uncertain, so we can't say that 6 has one significant figure. Also we can't say that 6 has no significant figures. Why? Because we can't say that it will violate the rule, it will contradict the rule that 6 is a number. 6 is a natural number, we can't say that. So what we assume that we can write 6 as 6.0000, like infinite 0. Thus infinite 0 will this will make the rules for the decimal number, counting of significant figures of decimal number, and according to those rules the number of significant figures will be infinite, because we are adding 000 after the decimal of 6. Okay, so this is why here it is infinite. Okay, if you are still confused with the concept, you can ask me in the comments. Okay, so now let us talk about the decimal numbers. Decimal numbers, we have simple rule. All the numbers after the first non-zero number, including that non-zero number, are counted as significant figures. For example, here we have this example. Here 5 is the first non-zero number. So all the numbers from 5 to the last 0 are counted as significant figures. And in this example we have 11 significant figures. Okay, here are also elaborated rules. If you want to note, you can note. These are optional, don't need to note, because simple rule is the always okay. Okay, so I have provided one more exercise for you for decimal numbers, so we can start now. Okay, so I'm starting the time. Okay, so the time is up and I'm showing the answers of the questions. Okay, so these are the answer. I will explain you here. 5 is the first non-zero number. So 500 are counted as decimal number, that is significant figures, and here 3 significant figures. Here also there are 3 significant figures. Here there are 6 significant figures. Here 2 significant figures. Here there are 1, 2, 3, 5 significant figures. Here there are 5 significant figures, and here 5 is the only one. So here it is no 1 significant figures. Easy. Like this, you can count the number of significant figures in any number by these two simple rules. The first one is for decimal number and the second one is for non-decimal number. You can just remember these two simple rules and you will be the master of calculating significant figures. You will be master in counting the number of significant figures present in any number. Okay, so let's move on. Okay, so calculations considering significant figures. You may ask me why we need to study about the calculations considering significant figures. What is its importance? Let me tell its importance by one example. Here, if in normal calculations 6 into 3 is equals to 18, but in signified calculations, or you can say in significant calculation, or you can say calculations considering significant figures, 6 into 3 will be equals to 20. This is the difference, a huge difference between the two numbers. In one side there is 6 into 3 is equals to 18, and on the other side there is 6 into 3 is equals to 20. A huge difference between those. Okay, now let us examine what is this difference, why is there so much difference. So let's move on. Okay, so now we will study about the rounding off of numbers. You may say that's why we need to study about the rounding of numbers. You may think that you are master of rounding off numbers, but it's not that thing. So I am giving you some examples. Okay, here we are giving some examples to you. Now you have to round off it. I will provide you 15 seconds and we will check that how much master you are of rounding off numbers. So we can start now. Okay, so the time is up and I'm showing you the answer. Yes. This is the answer. 0.068. I think all of you may have the answer right here. In this also all of you may be right. In this also all of you may be right. In this also all of you may be right. In this not all of you may be right. In this all of you may be right. So I think you may be right in the this one, this one, this one, this one, and the last one, but not this one. Why is there some change? You may say that so in earlier childhood classes we have studied that 6.5. If there is any number, if we have to round it to 6, and if there is 5 or any number above 5, then we will add 1 to this number and it should be 7. But it's not that. You are at an upper level now. It's not childhood classes. Rules are now a little bit changed. What are changed rules? Let us see. So suppose we have a number 0.065. We You may say that so the answer should be 0.07 if you round it off to two decimal places. You may say the answer is 0.07, but it's not that. Why it's not that? Because 6 is an even number. 6 is an even number. And whenever there is even number before 5, it will not change. Thus, but if there will be odd number, suppose we have an example here, 0.075, and we have to again round it off to two decimal places, then it will become 0.08, because 7 is not an even number, it's an odd number. So in this case, you can change. No, again check the last example. Here it is 4, and here it is 5. You may say, sir, 4 is an even number. Then why you have changed this time? What you have done this? You have you have made us confused. You may ask to me. And no, I will clear all your concepts. Here we have one. Here we have one. This rule is only applicable to those numbers which have 5 as the last non-zero number. It's only applicable to those number only. If any number has not 5 as the last non-zero number, then this rule is not applied. You can go with your childhood rule. Okay. For example, here 5 is not the last non-zero number. Thus, you will follow your childhood rules and then we will make it as 5. But in the next one, there is 6.5, and here you can see that 5 is the last non-zero number. Thus, you have to follow the rule of even and odd. So this is the rounding of numbers. Now you're gonna say that you are master of rounding of numbers. Okay. So let's move on. So we were talking about the calculations considering significant figure. So first we have the calculations of addition and subtraction. So whenever we add, where is my cursor? Over here. Whenever we add or subtract any two numbers, the number of decimal places of the answer must be equal to the number of least decimal places available in the operated numbers. For example, we have this number. You may say the answer, sir, the answer should be 87.040. and so then we will write it as it is 7.04. If we will do that like this, it will be wrong. It's not the correct answer. If you are considering significant figures, it may be right if you are just seeing the normal calculation, but it is wrong if you are doing calculations considering significant figures. Why it's wrong? Whenever we do calculations whenever we are performing operations of addition and subtraction considering significant figures, we must take the number which has the least decimal places, and we have to arrange the answer according to that number. In this in this question, in this example, in the first one there are how many three there are decimal places. There are three decimal places. In the second one there is one decimal places. In the last one there are two decimal places. The least decimal places are with the second number. So we have to arrange the result according to the second number. According to the second number. And whenever we arranged according to the second number, the answer must have only one decimal places. And if you consider only one decimal places, the answer should be 87.0. You can't write 87, you can't write 87.04, you can't write 87.040. You must write 87.0. Okay. Similarly, let's move on to the another topic. Okay, so multiplication and division. So how can you perform multiplications and divisions considering significant figures? Here it will be multiplication. Sorry, typing mistake here. Multiply, and at the place of subtract here it will be division. Okay. So whenever we multiply or divide at two numbers, the number of significant figures of the answer must be equal to the number of least significant figures available in the operating numbers. So what this means? Okay. So here we have 2.000. How many significant figures we have? We have four significant figures, and in the next one there are how many significant figures have? There are three significant figures. So in this case, the least significant figures are with the second number. So we had to arrange the answer according to the second number. And according to the second number, there must be only three significant figures in the answer. So we will write 110, 110 decimal. So what is the function of this decimal? What is the importance of this decimal? Suppose if you will write 110 only, then the rules of significant figures of decimal numbers will be applied, and according to that there will be only two decimal places. And if we will put 0.0, then there will be four decimal places, and we need only three significant figures. We only need three significant figures. So for in seek to make it three significant figures, we will make it as a decimal number. We will make it as a decimal number, and after making it as decimal number, we will only put one decimal. We cannot put 0 here. We will only put this decimal number, and the answer for our question will be right. Okay. So now we are end with here. I hope that the concept of significant figures may be clear to you. But if you have still any doubt, you can ask me in the comments. Comments are always available to you. So ready for the new sessions? Like this video, share this video, subscribe our channel along with the pressing of the bell icon, so that you can get the regular updates of the new videos which are going to come. Uh, you will get regular notifications. So friends, thanks for watching. Bye.